Okay, example 6. Now, consider the sequence. Again, you are given a recurrence relation. You are actually given that as n tends to infinity, un tends to alpha, which means it is convergent, right? Correct? Just by looking at this expression, you can tell that they're telling you that this sequence is convergent. Okay. Now we are to find the exact value of alpha. So which means you cannot use no GC. We cannot use GC because they ask for exact. You have no choice but use the algebraic method. Okay? So we use the same idea. If it's convergent, this term should be alpha. This un should also tend close to alpha. Okay, now we want the exact value. Okay, now time to get busy. I know some of you are falling asleep. If your friends are falling asleep to the left and right of you, please wake them up and do this now. Okay, not difficult to solve this quadratic. Alright, -5 plus minus root 21/2. How do we know which answer is correct? Just now I mentioned, right? Yes. In example 5, it was very obvious because all the terms should be positive. Because in the recurrence relation, there were no negative signs. But this is not so obvious because the first term is negative and then there's a negative, you don't know whether the next terms are positive or negative. So the easiest way is to use your GC. So if you use GC, you realize that, see, it tends to negative 4.791. Then you, then you check that it's this value that is negative 4.791. So you reject the other term. So that's the only way for this question. You use your GC. Alright? 10? Simple enough? Simple enough, huh? Okay. Okay. Let's go on to behavior of sequences.